We want to maximize our efficiency by spoon feeding the crop through the season, closer to when the plant needs it, getting biology out there like we've talked, and that does increase the nutrient use efficiency. So 3 practices to build carbon in the soil. Keep a crop growing as much as possible. And again, it's the root exudates coming off of a living root growing in the soil that's feeding the biology. And we think that's how soil builds the quickest, is just by having biology on an active root. 2 is recycle residues to replace carbohydrates. We're going to talk more about that. And then proper tillage. What is proper tillage? There's a lot of factors that go into that. It's not a one-size-fits-all. It depends on your soil type, your climate, how far north you are, how fast residue tends to decompose, the slope of the soil, what's the previous crop, what's the next crop. So there's a whole lot of factors. So again, cover crops allow you to keep a living root in the soil, feeding biology more days out of the year. We're capturing photosynthesis energy from the sun and converting it into biology and building soil. So we want to talk about recycling residues. This is a picture of the AgriEnergy farm here several years ago. There's the south border. This is one neighbor's field here. This is a second. You see there's a color difference there. Why is that? It's due to the higher organic matter, even though these fields have had basically the same tillage and the same crop rotation for years. But the main difference is how residue was handled and then adding biological products in the springtime. So in a 180 bushel corn crop, which is pretty modest by today's standards, there's 80 pounds of nitrogen, 30 pounds of phosphate, and 190 of potassium in the above ground portion of that residue. So if we can get that to break down rapidly, we can recycle those nutrients to feed the next crop. Plus there's also sulfur, calcium, and magnesium, and other micronutrients. So what is good residue management? 1, we want to till plant residue into the aerobic zone, or at least get it in contact with the soil. For the most part, the microbes that decompose residue don't live on the residue, they live in the soil. Generally, most times there's not enough moisture to sustain them on the residue alone. So that residue has to be at least in contact with the soil. We say here, till it into the aerobic zone. The aerobic zone, again, is that soil with oxygen in it. That's where your crumb structure is. Once you get below that, you get into a tighter anaerobic soil. And if you put your plant residue down there, it's not going to break down properly. We want to narrow the carbon to nitrogen ratio just like you would in a compost pile. We can do that with livestock manure, green manure crops, things like that. And then we want to avoid using excess nitrogen. Organic matter has a 10-to-1 carbon to nitrogen ratio. If we put up too much nitrogen, the microbes are going to burn carbon to get back to that ratio. So it's hard to build soil using excessive rates of nitrogen. What are the benefits of good residue management? Improved soil tilth. Again, we talked about how it takes an army of microbes to break down crop residue, and they secrete polysaccharides that glue soil particles together and create that crumb structure. So if we have rapid decomposition, improved soil tilth is the natural outcome. With improved soil tilth, we get a better seed bed. We have less weed pressure, again, because the soil can breathe. We're not trapping gases that cause weeds to germinate. We break down phytotoxic compounds. You know, maybe in some cases that's herbicides or pesticides, but there's also phytotoxic compounds just from breaking down residue. So we want that process out of the way before we start to grow the next crop. Less immobilization of nutrients or tie-up. You know, the microbes are going to eat first. So we want the bulk of that decomposition done before we're trying to grow the next crop, and we'll have more availability of nutrients. That gives us a faster start for the next crop, gives us a better chance or opportunity to capture maximum yields. So, how do we treat our residue? We want to inoculate it to accelerate the plant residue breakdown, putting organisms out there that do decompose residue, fungi and bacteria both. That can be done on cash crops or cover crops. The Residues WS is the product we use. That's a dry water-soluble powder. In most situations, it goes on at 1/10 of a pound per acre. That has the microbes in it that speed up the decomposition. But we want to put some kind of a food source with it, a sugar, a fish, a humic acid, something to jumpstart that process, get the microbes multiplying so they then go to work on the residue. So ideally, we'd spray this product on as soon as possible after harvest to give us more days of warm soil temperatures to break the residue down. I know in a lot of cases it just doesn't happen in the fall. Harvest gets pushed back and we're already into, cooler soil temperatures. So in that case, a lot of guys put it on in the spring at the first opportunity. And then the proper tillage to incorporate it. Again, what is proper tillage? It varies, anything from something not very aggressive like an airway to a disc ripper, or again, depending on your situation. But get it in contact with the soil. This is a picture I took several years ago of Valparaiso, Indiana. This is a no-tiller. He uses the airway here, applies the residues in one trip. Here he had 4 point rows that he didn't want to go back to the other end of the field and just to pick up 4 rows. And so he left them untreated, didn't get the residues or the airway. And almost missed this. We were been looking at crops and we're ready to call it quits. He said, there's a spot out in this field you might be interested in. And so we got to looking there, and you see without the residues, there's quite a few corn stalks left. Over here, they're pretty well gone. Here you'll see clods. Here you have nice, loose, crumbly soil. So again, if we speed up decomposition, we do change the soil tilth. Another thing that doesn't show up real well, there's a little bit of yellow on the edges of some of these leaves. There's some potassium deficiency there, which you don't see over here. So again, we've broken that crop residue down. We're recycling those nutrients. There's more potassium available for this bean crop over here. Just a factor on how tillage can impact water movement in the soil. Again, slide from Washington State University. Here we've got straw incorporated uniformly throughout the profile, and the water wicks down. Here it would be like turning it under with a moldboard plow, so you've got a matter residue. That inhibits water movement down through the profile. Here would be like a mini moldboard plow where you're laying the residue in vertical strips, and that actually enhances, especially if that strip of residue goes clear to the surface, it enhances the water infiltration. So again, you can see the line here on that AgriEnergy farm. So with permission from the neighbors, We tested that and found that we had 1% more organic matter in the top 6 inches of soil than the neighboring farms, same soil type, same tillage practices and crop history. What does that mean, having 1% more organic matter? That means we're storing another 1,000 pounds of nitrogen per acre. Is all that available to grow the next crop? No, but a percentage of it is. Generally, from 1%, you'll get anywhere from 20 to 40 units of nitrogen each year from your organic matter. You're also storing another 651 pounds of phosphate, 115 pounds of potash, 728 pounds of calcium, plus more water holding capacity, 83,000 pounds of water. So you're going to be able to weather dry spells more if we can build our organic matter. What does that really mean on the long term? This is kind of a summary from nitrogen rate plots we did on the AgriEnergy farm back in the 90s and comparing it to nitrogen rate plots that the University of Illinois did at the same time. We found on the biological program on that farm, it took 0.37 pounds of nitrogen to grow a bushel of corn after soybeans. The University of Illinois found that the most economical rate was 0.95 pounds of nitrogen. If we go to corn after corn, we're about 0.6 pounds of nitrogen to grow a bushel of corn on a biological program. And, you know, for years and years, Illinois said it takes 1.2 bushels of 1.2 pounds of nitrogen to grow a bushel of corn. And that's what their study showed. And a little less if you give a credit for after soybeans. So it's taking considerably less purchased nitrogen to grow a bushel of corn. Here's a field of corn on the farm following soybeans. It had 35 pounds of nitrogen applied at planting time, and that was over 200 bushel corn. Another savings is phosphorus. We're getting more phosphorus from the soil. The most phosphorus that farm got for 30 years was typically about 5 gallons of a starter. We're assuming every year. It wasn't in corn every year, so it didn't always get that much. If you figure that over a 28-year period, you grow 200 bushel corn, each bushel removes 0.43 pounds of phosphorus. So this is how much phosphorus was removed from grain from the farm. This is how much was applied, 420. So we have a deficit of almost 1 ton of phosphate per acre. So man, we must have really tanked our phosphorus levels on the soil test, right? Well, in 1981, the P1 level was 190. In 2009, it was 190. So again, we're getting available phosphorus from biology in the soil and building organic matter. So that's a huge opportunity to save money on input costs. So again, with P2O5, how can I use less and build levels? Phosphate solubilizing organisms like we have in the MVP, banned, used to reduce rates, feed the crop, not let it tie up on the soil. Mycorrhizal fungi that break phosphorus loose, like the mycoseed tree. Grow more biomass, a better root system, and then manage residue and recycle those nutrients. So what are the benefits of biological farming? Better tilth, increasing organic matter, which means darkening soils. When that happens, weatherproof, whether we get too much rain or too little, we're going to do better if we have more organic matter in our soils. reduced nitrogen and phosphorus inputs. We're growing higher quality, more nutrients dense. So corn that stores better. If you're growing produce, it's going to store better. Forages, we're going to have a higher quality product and then better yields also.
For helping share this morning.